Have you tried taking the derivative of this and then you get stuck because you get to this point and you're like, what do I do? This is pretty nasty, right? But in this video, I'm going to show you a faster way that's going to save you a lot of time and headache. We're going to use what's called implicit differentiation because in this original equation I gave you here, notice that cosine of y, you don't just have y by itself. This whole thing on the left means that we are dealing with an implicit relationship. So what I'm going to do is I'm just going to take the derivative of both sides of the equation individually with respect to x. And you might be wondering, well, how do I do that on the left here? Because y isn't by itself. And let me go ahead and show you. So you start by taking the derivative of this like you normally would. So for a natural log of something, you would just get 1 over that something, right? The 1 over cosine of y times the derivative of the inside function cosine of y using the chain rule. But then now you have to use the chain rule with implicit differentiation, because when taking the derivative of an expression that has y in it, but with respect to x, you now have to put in this dy over dx here. Now for the right-hand side, the derivative with respect to x of e to the 1 over x is pretty straightforward, right? You get e to the 1 over x, and then using the chain rule, you multiply it by the derivative of that power. So let's go ahead and simplify things a little bit here, so that on the left-hand side, we're just going to have negative sine of y over cosine of y dy dx. And on the right-hand side, I'm just going to basically bring that negative power of 2 for x to a denominator. And by combining everything, now we have this simpler expression. And you can already see that for dy over dx now, all we got to do is just isolate it on one side of the equation so that when it's by itself, we can get our final answer. And I'm going to just go ahead and divide both sides by negative tangent of y.